Okay, I'm going to be taking a look here at the only problem for 4.6. This is not something that I'm going to test you on the final, but it is a method that is used by computers to find solutions to things. So we want to use Newton's method. Now you can go ahead and take a look at the video. I did an example in video for sections. It's called 4.5, 4.6. Optimization Newton's method. It's one of our class videos, and it's about at the 2-hour 16-minute mark, 2-hour 15-minute mark. Anyway, here's the problem, and then here's the solution. I'll just show you it. You know, to approximate the fifth root of 23, we first set up a function. We use, basically you raise both sides of this to the fifth power, and then move the constant over to the other side, so you get this. Then you take your derivative, and then you use that formula that's in my video, and then you take a guess, and then from that guess you compute the next values, and you keep doing that until you till your eighth decimal place does not change. So it's kind of got cut off here, but anyway, it looks like it takes about 4 or 5 iterations of the formula to get to the approximated value. So that's it. I'm not going to go through that. Now for 4.7, let me bring this up. Close out 4.6. This is going to be the last section that we will have. Let me bring this in so I can work through things. Okay. All right, so here's 4.7. Find the most general antiderivative of the function. So what we're going to be doing primarily on this problem and the next few problems is using the fact that if you're given x to the n, we're using power rule, then the antiderivative of this will be 1 over n plus 1 x to the n plus 1 plus some what we call constant of integration. So because I have 3 terms here, 1, 2, 3, and all of them are just powers, what we can do is we can just do each one individually. Now for 1/2, the antiderivative of 1/2 is just 1/2 x. And just think of it this way. If I ask you to take derivative of 1/2 x, you would get 1/2. So anytime you have a constant and you do the antiderivative of it, then it's just that constant times x, and then plus capital C, constant of integration. But we will throw our constant onto the end of this. So we get 1/2 x there, and then we have plus 5/6, and then what I'm going to do is do the power rule on this part right here. So in this problem, the n here is 2, so I'm going to use this formula with n being 2. So it'll be times 1 over n plus 1, so 2 plus 1, times x to the n plus 1, which is 2 plus 1. Okay, that takes care of the middle term. Now I'm going to do this last one. So I'm going to say minus 5/6, and then I'm going to do power rule on x to the third. So in that one, n is 3. So the formula says it'll be 1 over 3 plus 1, x to the 3 plus 1. I'm going to erase this. And then finally, plus our constant. And now just kind of clean things up here. That's equal to 1/2 x. That's this part. This right here is 1/3. And I multiply straight across. I get 5 times 1, so I get plus 5. Over 6 times 3, 18. And then I have x to the third. And then the last one here, so I've done this. Last part here, again, this is 1/4. And then I multiply straight across, so 5 over 6 times 4 is, we'll have negative 5 over 24. X to the 4th power, that's this. And then plus c. So that's our general antiderivative. Same thing with this one. I'll go a little faster here. 8 is in front times, now the plus 1 is 10, x to the 10. Then I have minus 4 on the next term, working on this. Then x to the 6, so times 1 over 6 plus 1 is 7. X to the 6 plus 1 is 7. Then plus 13. And then power here is 3, so 1 over 3 plus 1 is 4. X to the 4. And then when I get to the end, I add my constant of integration. 8 times 1/10, I can reduce that. That's 4/5. X to the 10th. And then right here, put those together, I get negative 4/7. X to the 7th. And I put these two together here, plus 13/4. X to the 4th, plus my constant. All right, for this one, this is a pretty important one. I'll take a look here at the answer. What we're going to do is, because I have 1, 2, 3 terms over a single term, I can split this up and I can make it 4 over root t plus t over root t plus t squared over root t. That's the same as 4 over t to the 1/2 plus t over t to the 1/2 plus t squared over t to the 1/2. So all I'm doing is rewriting this problem. And now I can move all the powers on the bottom. Well, I can move this one up to the top, so that's 4t to the negative 1/2. And then here on this next one, I have a 1 here, I have a 1/2 here. So I take 1 and I subtract 1/2. That's going to give me 1/2, so I have plus t to the 1/2. This one I have a 2 and I have a 1/2 down here, so I subtract. 2 minus 1/2 is 3/2. So t 3/2. So that's what the original problem is. And now what we do is we find the antiderivative. So what we'll do is we'll use power rule here on this first one. My n is negative 1/2. Now the 4 is going to sit out front. I'm going to take 1 over n plus 1, so negative 1/2 plus 1. And then t to the n plus 1, so negative 1/2 plus 1. Let me just focus on this one right now, and then I'll come back and do the rest. Right here, 1 over negative 1/2 plus 1 is 1/2 on the bottom. But 1 over 1/2 is the same as 2. And then t, and then up here, negative 1/2 plus 1 is 1/2. So what we get is 8t to the 1/2. And that matches up with this. Now let me look at this next one. So I'm talking about this one right here. So to do that one, n here is 1/2. So I'm going to have 1 over, this time 1/2 plus 1, t to the 1/2 plus 1. 1/2 plus 1 is 3/2, so I have 1 over 3/2. T to the, again, 1/2 plus 1 is 3/2. And then 1 over 3/2 is the same as 2 over 3, so it reciprocates the denominator. And then I have 3/2 here, so that's this. And then the last one works exactly the same as the one before. So I'll do 1 over n, which is 3/2 plus 1, t to the 3/2 plus 1. 3/2 plus 1 is 5/2, so this becomes 1 over 5/2, t to the 5/2, but then this reciprocates and gets 2/5, so that's this. And then you add your constant at the end. All right, for this one, just rewrite it real quick. This is 2x to the 1/2 plus 3 cosine x. So on this first one, I'm going to have the 2 in front. The antiderivative of that, you have 2, then 1 over, you do the n, which is 1/2, plus 1. 1/2 plus 1 is 3/2, so 3/2, x to the 3/2. Plus, now that we have a constant in front, 3. And then the antiderivative of cosine is sine, because the derivative of sine gives you cosine. So the antiderivative is sine, plus our constant. This becomes 2/3, which multiplies times 2 and becomes 4/3, x to the 3/2, plus 3 sine x plus c. Okay, so on this one, I'm just going to walk through this. We are given the second derivative, and we want to get back to the original function. So we have to do the antiderivative twice. So we start with this. We do power rule on x to the 3rd and get that. Then we do this one. We do power rule on x squared and get that. And we get 8x. We do power rule on x and get this. And then we kind of clean that up. Oh, and we have our constant of integration, and we get this. So that's the antiderivative. So this is actually f prime, because it came from taking the antiderivative of f double prime. We did anti, and that gave us the f prime. Now we need to go anti one more time to get us to f. So for this one, I take the 8x to the fourth. I do power rule on x to the fourth. Gives me this. I have the 8 out front. Here we have -6, then do power rule on x cubed and get that piece. Here, power rule on x squared, get that piece. Clean that up. Also, antiderivative of a constant is a constant times x. And then, because I'm doing antiderivative again, I need to add another constant, but I can't use c because I already used c, so I use d instead. Clean all this up, and you get this right here. Then you're plus cx plus d. Same exact problem here. Let me work through this one. We have 2/3. I'm doing the antiderivative times 1 over. Now power here is 2/3, so 2/3 plus 1 x to the 2/3 plus 1. Okay, 2/3 plus 1 is 5/3, but then we reciprocate it and it becomes 3/5. So we have 2/3 times 3/5. X to the, we already said 2/3 plus 1 is 5/3, then plus a constant. So the 3's cancel here. I just get 2/5 x to the 5/3 plus a constant. Now that is f prime. So I have to antiderivative one more time. So I will take the 2/5, put it out front. Now I do power rule on this. So that's times 1 over 5/3 plus 1 is 8/3. X to the 8/3 plus the antiderivative of a constant is the constant times x, and then plus our constant of integration d. Flip this over here, put the 3 on top, multiply by 2. 6 over 5 times 8 is 40. X to the 8/3 plus cx plus d. And we could reduce that fraction too, but I'll just leave it like that. Okay, on number 7, I will have to clean this out of here. Give myself some room. Okay, so we have to do the antiderivative. We start here. I'm going to do the antiderivative one time. So if I do the antiderivative one time, so here's our f double prime. We do the antiderivative one time, we get f prime is this. That's just using power rule. But here's the important thing. I'm given that the derivative at 0 is 18. So that means when I come into this derivative right here, and I plug in 0 for x, here, here, and here, that this should turn out to be 18. So that means that would go away, that would go away, that would go away, and so all we're left with is c is 18. So if c is 18, then I can rewrite my derivative right there, right here, but I can replace that c right here with 18. So that's what f prime is. Now what I do is I take the antiderivative again. So when I do the antiderivative of this piece here, I get this right here. Now I'm getting in my own way, so I'm going to have to get some stuff out of here. So I do the antiderivative again, and then I have a new constant of integration, which we call d. Now again, the fact that I know that the original function, when I plug in 0 for x here, 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 that should be equal to 9. That means that d has to be 9. And so what I can do is I can rewrite this original function right here, replacing the d with 9, and that would give you this final answer as to what f is. Now, just be careful, because it doesn't always turn out that when you plug 0 in, this number here is what your constant is. Like if this said f of 1 is 9, then you have to plug 1 here, 1 here, 1 here. I'm sorry, I'm in the wrong place. 1 here, 1 here, 1 here, 1 here, and then d, and then that would be equal to 9. And if you plug 1s in here, it doesn't turn out to be 0, so they don't wipe out and just leave you with d. So you would just have to work those numbers moving to the other side, and you'd figure out what d is. Oh, wow, that's it. Okay, that's all.